Good evening, everybody. Now, I haven't made a video for a couple of weeks now, and I haven't actually mentioned my final year project, so I thought it was about time I try and do something. My final year project in itself, I don't want to tell you too much about it, because I do plan maybe in the future to pursue it commercially. But there's a few sort of bits and bobs which are kind of interesting, I haven't personally done before, so I thought it was worth throwing up a video quickly. In front of you there is a little PCB that I've made. It basically is used for monitoring mains electricity. It's hooked up with a microcontroller, which obviously can only cope with about 5 volts DC, or in some cases, some PIC microcontrollers prefer 3.3 volts DC. Now, mains is obviously 230 volts AC, alternating current, and there's no way the microcontroller could possibly cope with that. So we have to change the AC voltage to DC for a start. And we also, I personally, although it would probably work, I didn't really want to risk merging the two sources of power, the mains and the power for the PIC, if you like. So I wanted to use a relay, and that's what that box is just there. A relay is basically a single pole double throw switch. It has two states depending on the input. And the little black thing behind there, you can just see, that is the full wave rectifier. It's basically a diamond formation of diodes. There's loads of stuff about that online. I might even put something up later on. I don't want to go into that right now. But that just changes for the AC to DC. And I made a little mistake, I have to admit, when I first played around with this. I read and had a look online, and a lot of people have used copper strip board in the past to play around in one way or another, probably dangerously, with mains electricity. And being a little bit safety conscious, I tied everything down to the deck. As you can see, I've screwed this board down as well, and attempted to stop any possibility of floating cables. Anyway, I carried on. I basically did what I just said on the copper strip board. The relay itself was it's rated up to about 240 volts AC, and I made the mistake of obviously converting it to DC. So although it can cope with that sort of level of AC, it cannot cope with that level of DC, and it caused a little explosion. The the side of the relay case popped off and had a little tiny flame, so that was fun. Not really a big deal, I just blew it out. But yeah, so be careful if you ever play with this. This is my first real attempt of playing with mains electricity. Well, I've obviously wired a plug and things like that, but I've never done more than that really. So so the next step, I went back to the drawing board and used a step-down transformer, which is the big thing behind, and that converts the 230 volts mains down to about 15 volts, and then again it just goes through the full wave rectifier, converting it to DC, through the relay, and off we go. The two cables you can see coming across are just from a regulated power supply, providing about 5 volts or so DC from the board which is connected to the microcontroller. And there's a little LED on there, and basically the idea is when the power is off as you currently see. When I plug the mains in a second, the LED should light up, and obviously there's a couple of header pins you can probably just make out in front of the LED. And I could put a cable running from there to the PIC, and obviously it will be able to register the input change. So I'll quickly fire that up 1 second. Now you've probably heard that little click there. Now the relay is a mechanical switch, and that was what you heard. Just turn over there. The LED came on quite happily, so it's working perfectly. If I just whiz the camera around, I apologise if there's a bit of a groany noise. It's not very good. 1 second. Yep. Actually, it might be better if I just hold it in my hand. There you can see a circuit diagram. Now, I haven't used this piece of software before, so this was interesting for me. I've only used sort of more basic software, sort of high school level software in the past. And I wanted to create a PCB, which is over here, as you can see. I just put 3 next to each other, might as well make the most of it. And they're all the same. So that's that. And if I quickly whiz over, so you can see the back of the board. Give it a second, the camera. There we go. You can see the screw terminal there. That's where the main supply was powered in, and you can see the cable running off there down to the plug. And I put a few header pins on there as well, as you can see. That was just to allow easy access for multimetering just in case something went wrong, or I wanted to see the exact voltages at each of the points before and after the components. So that's really the board. That's kind of the first step, and I will keep you posted with any future developments. Thank you for watching, and I will see you later. Bye bye.